Okay, so let's take a look at the warm-up. This is absolute value equations. Can someone raise their hand and read off all 7 values of the parent, what we call the parent function, which is the original function? Aaron, go ahead, please.
For the first one, 3, 2, 1, 0, 1, 2, 3.
Well, duh, right? It's absolute value. Whatever we put in is going to jump out positive. So it should be your graph. Raise your hands if your graph looked remotely like this. Good. That is what your graph should look like. Okay, who can raise their hand and read off the values for number 2? Because that one should be a little bit funny. Catherine.
2, 1, 0, 1, 2, 3, 4.
Okay, now, how does that impact the graph? What did your graph look like? Who can raise their hand and describe the change in the graph right there? Jared.
It was just like the first one, except shifted to the left.
Yeah, it was the same graph, except here it was centered at -1, 0, which is actually this point, right? It just shifted to the left one. And then who can go ahead and raise their hand and read off, what do you call it? The last one. Andres.
4,
Uh-huh.
3, 2, 1, 0, 1, 2.
Excellent. And who can raise their hand and describe that change? How was that graph impacted? What happened to that graph here? No, Amol, what happened to your graph?
It was the same as the first one, but shifted to the right.
It was the same as the first one, except it was shifted to the right, right? So raise your hands if you have all 6 that correspond like this. This is what all 6 of your answers looks like. Good. Okay, the pattern, well, who can raise their hand and take a guess? What is the connection between what's happening on the inside of the absolute value and how it affects the graph? Jared.
If it's x plus 1, it got shifted to the left,
Yeah.
and x minus 1 got shifted to the right.
Okay, good. So let's see if we can put this in our notes somehow. Absolute values, like parentheses, are what we call grouping symbols, right? The thing is inside something, which means something's happening to the inside before we take the absolute value, right? So, for example, -3. It was -3 plus 1. We added that to get -2, and then we took the absolute value to get +2, yes? Okay, so this +1 right here shifted the graph to the left 1. So who can put that in words? How could you put that in words? How could we come up with a general rule for how this works? And compare it to the right one. I'll give you guys actually a couple of minutes to think about that. Hold on for a second. Okay, so whatever's happening inside the grouping symbol is opposite your intuition. So this y is equal to the absolute value of x plus 1. We would normally expect that to shift to the right one, right? Because it's +1. Yeah? So in this case, it shifted it to the left one. And then same thing for the y. It is x minus 1, but it shifted it to the right one. Does that make sense? Okay, so now if I was to say, give you a random example of, say, number 4 up here. I'm going to throw you guys number 4. And you guys don't even have to do a table anymore. If I gave you y equals absolute value of x plus 12, can someone raise their hand and tell us how is that graph being shifted? Jared.
-12 on the x-axis.
It's going to shift to the left 12, placing it at -12, and your graph looks exactly as it did down here, except it's going to be shifted to the left 12. Does everyone follow that? Right? So likewise, if I give you y equals absolute value of x, let's say minus, give you something really, really crazy, the square root of 21. Okay? Where is that graph going to be shifted? Where is that graph going to be shifted? Robert? To the right. How many times? Whatever rad 21 is, right? I don't know what that is. But to the right, rad 21 times, it's going to be shifted to the right there, and it's going to maintain its normal look. This right here, this y equals absolute value of x, this is what we know as a parent function. Okay? Parents, and then this would be not a child function, but, you know, notice how everything is kind of born from the absolute value of x. All right, all the different graphical changes. Raise your hands if you have any questions on transformation so far. When things are inside the parentheses, they're opposite your intuition. Now, I'm going to give you guys a few more. I'm going to give you guys 2 more tables to do. And actually, you know what? I don't think we even need the table. Let's do it anyways. Who cares? Jessica. Okay, see ya. All right, so let's take a look at number 7. I'm going to give you y equals absolute value of x plus 1. And then 8 is going to be y equals absolute value of x minus 1. And then I want you guys to do the same thing. Instead, just go -2, -1, 0, 1, and 2. Make it shorter. Okay? We'll come back in a second. Okay, who can raise their hand and read the values for number 7? Read the values for number 7, please. Aaron, what do you got?
Me?
Yeah.
Okay. 3, 2, 1, 2, 3.
3, 2, 1, 2, 3. Okay, now, please let us know. Did your graph look like this?
Yes.
Yes, raise your hands if your graph looked like that. It was shifted up 1. Good. I'm not even going to go into this yet, but if you didn't get this far, I'm actually very glad, because based on the function y equals absolute value of x minus 1, what would you logically expect that graph to do? Jared? Go down 1, right? This is shifted down 1 this time. And in this case, the values are what? What are the values? Eric?
1, 0, -1.
1. Okay, good. So, the thing that I want you to get from this is when things are happening outside the grouping symbol. Outside grouping symbol. Does it go with your intuition or opposite your intuition? With your intuition. Goes with your intuition. So this is going to come back when we graph parabolas. All right? It's going to come up when we graph parabolas. And then, yeah, Justin.
Well, if you have something inside the absolute value and inside and outside.
Okay, Speed Racer, hold on. Hold on, Speed Racer. We're still building the Mach 5 right now, okay? Good question, though. You have no idea what I'm talking about, do you? Speed Racer? Okay, okay, good. Okay, good. All right, can I erase this? Outside the grouping symbols is with your intuition? Okay, so I want to ask you guys, to start using some, whoa, not that. I want to start asking us to use a little bit of sense. And I'm just going to give you a function now, and I want you to guess what's going to happen to this function. Y equals negative absolute value of x. What do you think? How does that affect the function? Take a couple seconds and talk amongst your groups and see if you can figure it out. Who can raise their hand and tell us what happens to this graph? Max. Okay, upside down. So the negative flips graph upside down. Take a guess. What happens to this function 2 times the absolute value of x? What's going to happen to 2 times the absolute value of x? Javad. It's skinnier by how much? Twice as skinny. Oops. 2 times skinny. So this is going to shoot up a little bit faster because it's growing twice as fast, right? If I plugged in 100, it's now 200, right? So now, if it was 12x, how much skinnier would it be? Much, much skinnier than 2 times x, right? Okay. How about, last one, y equals 1/4 absolute value of x. How does that affect the graph? Justin. Gets wider. This one's going to grow, whoa, that looks kind of like the parent function. It's going to grow a little bit wider. Okay? Because it's a fraction that is less than 1. Raise your hands if you need an explanation of that. Okay, so I'm going to give you guys maybe like 2 problems to do on your own. And actually, just kidding, I'm not going to do that yet. I'm going to go over a couple of shifts with you that are simultaneous, because in your assignment for tonight, you will encounter absolute value graphs that have multiple things happening to them. So I'm going to give you, let's revert back to example 1 here, y equals, say, absolute value of x minus 3 plus 7. Now, in terms of the graph quality, I don't need it to be astronomically wonderful. I just need to know that you know where the graph is being shifted. So, first shift. Who can raise their hand and tell us what is the first shift of this graph here? Lucas. 3 to the right. 1, 2, 3. That's all I need. 3. And then, where's the next graphical shift? Amol.
It goes 7 places upward.
7 places upward. You know what? I'm going to just go ahead and label that and call that 7 because we can be a little bit lazy on this one. That's the center. Is it facing up or is it facing down? Joshua? Facing up because it's positive, right? And that's as far as you need to go on your assignment tonight. Okay? Number 2. If I give you y equals 3 times the absolute value of x plus 5 plus 2, who can raise their hand and in one complete shot describe this graph? Describe this graph in one complete shot. Madison, what do you got for us?
It'll be negative 5 on the x-axis.
Uh-huh.
And it'll be up 2.
Okay.
And then it'll be 3 times skinnier.
3 times skinnier than usual. Good. Okay. Now, what if I decided, change to catch up here, what's this graph going to do? Eric. It's going to move downward. It's going to be the same exact graph, except it's going to move downward. Okay? Aaron.
How'd you get the 2 negative 5?
Okay, remember, opposite your intuition, it moves to the left 5. Because it's inside the grouping symbol.
Okay.
With your intuition, it goes up 2. Okay, Aaron,
The 3 is the skinny.
the 3 controls the rate of growth. Aaron, you ready? Because the next one's for you. Y equals, Joshua, give me a number, please. 4. Negative or positive? Positive. Absolute value of x. Kiyomi, give me a positive number or a negative number. I don't care. 5. Positive or negative? Positive 5. Let's see. Luke, give me a positive or negative number. Negative 5. Okay, Aaron, this one's yours. Which way is it going on the x-axis?
Negative 5.
To the left 5. Whoops. That's to the left 1. To the left 5. Where's it going now? Okay, we took care of this part. What's next?
Wait. Down 5?
Down 5. Is it skinny, wide?
4 times skinnier.
4 times skinnier. Boom. You're done. Okay? Jared,
So you don't want us to
make a table.
tell how skinny it is,
Just make it skinny. I'll be able to tell. Okay? Basically, it's for you guys to just be able to sketch and know what it looks like. Cool? All right.